Okay. So, okay, hold on. Okay. So for this part, you already learned about decoder. Okay. 2 to 4 decoder, right? Okay. Where you do selection.
Yes, Doctor. Yes.
I0, I1 enable pin, Y0, Y1, Y2, Y3. And also, this one also consider encoder. Okay. This one BCD2 7 segment decoder, which is we have BCD input and your output is BCD 7 segment lah. Okay, ABCD until G. Okay, so decoder in Verilog you have 2 to 4 decoder. Okay, this is the truth table for your decoder lah, 2 to 4, where you have enable. Okay, 0 means not enable lah. When you put 0, your output should be 0 lah, right? Okay, because you
Yes, Doctor.
disable. Okay, you disable that IC. Okay, so when you enable that IC 1111, so you have two inputs 0001 1011, and these are your output. So when your decoder input 00, you will get Y0. So the channel 00 to Y0. It's like switching lah. Okay, so Y0 will be turned on and the rest are zeros. When you use 01 for your I1 and I2, you will get 0010, where you turn on pin number Y1. Okay, so the rest is 0. And when you use input I1 as 1 and I0 as 0, you will turn on pin number 2, Y2. Okay, and finally when you turn on both 1, 1, you will turn on pin Y3. So this is the truth table that you already learned. So how to convert to Verilog? So of course first you declare module. Okay, module. This module you can name anything lah, not really decimal 2 to 4. You can decoder 2 to 4. Maybe you want to label as box, square, right? Something, any name will work lah. But because this is decoder, so they label as decoder 2 to 4. Okay. And then put all your parameter, input and output inside this column. Okay. So open this one, you put enable because you have enable pin, and then you have I0 pin, and then you have I1, and then you have output Y0, Y1, Y2, Y3. Okay, so far clear? You put everything inside here. Okay.
Yes, Doctor.
And then you declare the input and output. So you declare input as enable, okay, and output as output. So your input is enable, I0 and I1, where your output are Y0, Y1, Y2, and Y3. Okay, then put the semicolon to close your statement. And then we use the easier one, which is we use assign statement. Okay, assign statement. You want to assign Y0. Okay, you want to assign the Y0. So Y0 equals to enable. Okay, enable. Because enable is the main pin that you want to always turn on. Okay, only when you once you turn on, only then you can make the next calculation. Okay, so you must put n lah. Okay, when n number is 0, n with everything you will get 0. So same like this truth table lah. Okay, so that's why you put n. Okay, and next you for y1, so for y0 first, so y0 enable must be 1 and not I1. Okay, not I1. So because your I1 is 0, so you must put the not lah. Not means you want to inverse it. Okay, inverse from 0 to 1. So you will get I1 to 1 and not I0. So I0 also you want to 1. Only that you will get Y0 equals to 1. Correct? Okay?
Yes, Doctor. Yes.
Alright. Next, assign. So assign is the easiest statement lah, because straight to the point. Okay, you use the Boolean expression. Okay, Boolean expression to describe your program, Verilog. So assign y1. So you know y1 is here. Okay, so assign y1. You know that enable must be 1. So enable, and so you see I1 is 0. So you must put not. Okay, to get 1 you must put not. So not I1. Okay, so this is symbol for not I1, and I0. Why not? Why don't have not? Because already 1. Okay, already 1. So you put I0. Okay, semicolon. For y2, equals to enable, and because I1 already 1, so you put I1. Okay, and I0 is 0, so you must inverse it. So you put not. Okay, not I0. So total, the answer y2 equals to 1. Okay, same with this table. And finally, y3. Okay, so y3 enable, and okay, I1 is 1, so you put I1, and I0 is 1, so you put I0. So total up, you will get y3 equals to 1. Okay, then you close your Verilog program with N module. Okay, clarity?
Okay, Doctor, understand.
Okay, so let's say I change this table, table to different number, so you should be able to put whether not or not. Okay, whether they have not or not, depends on 0. If 0, you must put not lah, to inverse it to 1. Okay, next operator in Verilog. So one of the operator is equality. Okay, equality, not equal. Okay, this one logical inequality, case equality, and case inequality. Actually, the functions are quite similar lah. Is some sort like equal, but sometimes they just change your clock. So maybe your answer is you will get some lagging, maybe one clock behind, or one clock after your end operation. Okay, so this one we can prove during the simulation lah, the difference. Okay, but this is the term lah. Okay, just the theoretical term. Okay, conditional operator for multiplexer. So this is a multiplexer that we discussed last class. Okay, so let's say the program for multiplexer, data flow coding. Okay, data flow coding using Boolean expression. Okay, so module multiplexer 2 to 1, because this is 2 to 1 multiplexer. Okay, and then you put your input and your output. So your input is I0, I1, A, okay, A, and your output is Y. Okay, so everything inside the bracket, and then semicolon, don't forget semicolon. Okay, and then input, you have I0, I1, and your input also A. A is a selector lah, okay, for your multiplexer. Output for Y. Okay, so use assign, okay, because this is data flow coding. Okay, data flow coding, use assign Y. So you want to assign Y is the output, which is Y. Y equals to Z lah basically. Okay, Y equal to Z. This is the output. So your program is Y equals to bracket, not A, and I0. Okay, where I get this equation from? This. Okay, from this equation that we proved last class, right? This equation we proved from the table. Okay, so from this equation I convert to assign Y equals to A bar here, right? A bar means not lah, not A. Okay, not A.
Understand, Doctor, understand.
Okay, multiply. This is multiply. Multiply, you replace with N. Okay, multiply, you replace with N, and then you have I0, so you put I0, plus you replace with OR. So this is OR lah. OR where? This one OR. Okay, this one OR. Okay, so OR operator, you use as OR operator, bracket, A as A, multiply as N, and I1 is I1. Okay, so you convert this equation to Verilog code. Okay, and then semicolon, end up with N module. Okay, so when later we do the simulation, we can simulate this output by using the Verilog or by using the Quarters tool. Okay, Quarters tool software. Okay, next, data flow coding using conditional operator. Okay, you can see the program are similar, but you need to assign the code based on conditional operator. This one boolean. So where is conditional? Conditional operator is here. Okay, conditional operator is here. Okay, conditional operator. So how to write the conditional operator? Okay, do you have any idea? Conditional operator?
No, Doctor.
No? No idea? Not yet?
No,
Okay. Okay, it's okay. Okay. Conditional, we move to next lah. Okay. So just later we will come back. Okay, to apply the
Okay,
conditional.
Doctor.
Okay. So let me make you see the gap that you have to know lah after this. Okay, decoder in Verilog. So next we move to decoder. Okay. Okay, 2 to 4 decoder. Okay. This one you already learn in digital lah about this table. Okay. 2 to 4 decoder. Okay. So your module would be module decoder 2 to 4. Okay. Enable. Okay. Put all input and output. Okay. So you have enable I1, I0, Y0, Y1, Y2. So enable I0, I1, Y0, Y1, Y2, Y3. Okay. So you declare your input. Input enable I0, I1, output Y0, Y1, Y2, Y3. Okay. So how to make the program? I try to edit. Okay. Okay, so you already know from the previous table you assign, right? So I already show or not? This one. This one.
Then that's already.
This one, right?
Yeah, done already, Doctor.
Done already. Same, right? Same,
Yeah,
right?
done.
Oh,
Done.
done. Yeah, done.
Input.
Mm-hmm. Okay. Okay, so done.
This done.
Done. Okay, same. Okay. Decoder using conditional operator in assign statement. Okay. So first module, then declare, right? Okay, like this one. Okay, easier for you. Try copy paste because the structure almost similar. Okay. 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 Module 224. Okay. Then you put your input, all of your input. So you have input A, B, C, D. Sorry. Okay. A, B, C, D. Your output would be small a, right? Small a.
This is the small a, small b, small d, small c.
Small d, small e, small f, small g. Okay. Okay, then you close. Semicolon. Okay. Then declare your input. Input A, B, C, D. Right? Okay. And then output small a.
Small a, small b, small c, small d, small f.
Small f, right?
Yes, Doctor.
And then what you want to you have to do? Assign, right? Okay, so you can do assign. Okay. So assign. Oh, this one quite long. This one quite long.
Yeah, yes, that.
Okay. Never mind. I will open Word lah. Easier for me to write.
Okay, that can.
Okay. So can you see my Word?
Yes, that. Yes.
Okay. So this one all on. We copy the table. Okay. We copy this table first. Oh. Oh, cannot do formatting ah.
Can that can.
Never mind ah. Hold on ah. Hold on. If in class I can draw you.
But it's online, so I can just hold
Yeah.
that.
1, 2, 3, 4, 5, 6, 7, 8. Okay, hold on ah. Take some time. I want to write the table. So that easier
Can
for
do
you.
that. Can you can.
Later I can share with you this one. So easier. C D A B C D E F G. Okay. Zero one zero zero 0101 0110 0111. Sorry. Okay, 0111. Next. One thousand 1001. So this BCD 100. Okay. So first we declare the module. Okay. Okay, so I want to introduce you. Before this, you use assign, right? Okay, you use assign.
Just that.
Now I will introduce to you new term, which is case. So we will use case statement. Case.
Okay, that's that.
Okay, case statement. Okay. So module. So I declare my module. What name you want? 7 segment. Because 7 segment. So I use segment. Okay, 7 BCD LED. Okay, LED. Okay, and then I declare my input. Okay, where I get BCD, this one the BCD. Okay, this one BCD number lah. Okay, this one BCD. Okay, this one LED. Okay, so I declare first BCD and LED. Okay, and then input 30 BCD. Okay, like remember in the first class I taught you about this one 3010, right? If 2 bits, 1 to 0, right? 2 bits.
Yes, sir. 0.
Okay, remember, right? Okay, 2 0. Okay, and so on lah. 4 bit, 3 0 and so on. Okay, so now how many bit for BCD? How many bits? 1 2 3 4. Okay, so 4 bit you use 4 bit you use 3 to 0. Okay,
Okay, doctor. Okay.
right. So okay. Okay, then after input you declare your output. So output how many bit? 1 2 3 4 5 6 7. Okay, so if 7 means 6 to 0. Okay, so you can put 6 to 0, or you also can use 1 to 7. Okay, 1 to 7.
1 to 7.
Same. Yeah, same. Okay, so I want to code with different thing, so I use 1 to 7 lah. Okay, so that you learn more. Not only you always use 3 to 0. Okay, you use output 1 to 7, same. Okay, 1 to 7. And then what is the name for output? LEDs, right? LEDs. So you put LEDs. Okay, semicolon. Okay, and then because your output, you need to store your output, right? You don't want when your result is written, you don't want it to disappear. You want it to be maintained, right? You want to store the information, right? So you store that in the memory. So memory we call as register. So register, so your output you declare in the register. So this small Okay. So this one also small. O small, I small. Okay. So register because the input bits are similar for LED. So you use the same name. Okay. So basically when you have your output, you need to put your register. That is the simple formulation lah to be remembered. Okay. Basically if you put output, we always put register. Okay.
Understand.
All right. Next, we move to loop. Okay. This is the main program lah. Loops. Always. So add. So that loop, what is the main number that you want to test? You want to test this number, right? You want to test this condition, right?
Yes,
When
BCD.
this happen, when this number happens, what output, right? So
Yes,
this one
sir.
you put into your input. Okay, you put into your input, which is B, C, D. Okay, for always, no semicolon lah. Okay, no semicolon. Okay, next I teach you about new statement, which is case. Okay, so case. Okay, sometime in Verilog, when you put shift, they will put some shift lah, okay, to differentiate between first line and second line. So case BCD, okay, this number you want to put to this case, okay, and then you put case what case? Case, this one case 0, right?
Yes, sir. Yes, sir.
Sorry, this one. If case 0, all 1, right? So you will get on,
Yes, sir.
on. Okay, you will get all 1. Okay, all 1. Okay, so this is the case 0. Okay. 1 1 1 1 1 1 1 1 0. Sorry, B and C. Okay, so case, okay, then case 0 dot LEDs. This one easier lah, straight to the point when you see the code. 7. Why 7? Because 7 bit, right? Based on lecture on Tuesday. Okay, the size of the bit. 7 unit, bit, right? So bit. Okay, 7 bit. Oh, sorry. This table is not correct. I need to change this table lah. Later I change the table lah. That's why I feel not correct. 1 0. Zero, 1 1. That's why I feel different, because this one 0 means G is not turned on. So G should be turned off. Then you get 0. Right? Okay. So maybe they change the number. Never mind lah. Numbers just the example. Okay, I change to the correct one. 0 0 1 0, which is 1 1 0 1 1 0 1. Okay. 0 0 1 1. 0 0 1 1 1 1 1 1 0 0 1. 0 100. 0 101. 110. 110. Sorry. 0 1 1 0. 0. Okay. 110. 111. 0 1 1000. And 101. 1001. Okay. So this is BCD numbers lah. Sorry. Okay, why I change to the correct one? Because I want to turn on the LED. Okay, I want to turn LED properly. For example, this one. Okay, for example, this one 000 means you want to turn number 0. So you turn off G. So I turn off G. So you get 0, right? Okay. This one 001 means number 1. So 1 you want to turn on number 1, which is BC or FE. So this one they turn B and C. Okay, so you turn B and C, you will get number 1. Okay.
Oh, okay, understand.
So that's why now you understand, right? Why I changed the table? Because I want
Now I understand.
because I want to relate with the 7 segment. Because later in practical you will appreciate lah. You will appreciate this table because you need to write numbers later. Okay, so that's why I straight away teach you. For the slide, they basically just use the example. So that's why they don't care about the number. Okay. So next, this one 0, 1, 2. This one number 2. Okay, this one number 2. So number 2 should be this one and this one, right? Number 2. Okay, this one A, B, G, E, D. So A, B, A, B, D, E, G. Okay, same lah. I speak G first. Okay, next 4. So 4 here. So okay, 4 here. So A, B, C, D, 1, 1, 1. So A, B, C, D. So this one is 1. Okay. E, F, 0, 0. So only E, F. E and F, 0, 0. So E and F. So this one is 0, 0. So you will get number 4, right? Can you imagine that? Okay, number 4. Okay, number 5 should be here lah. A, F, G, C, D. Okay, A, F, G. 0, 1, 2, 3, 4. Sorry. This one number 4. Sorry. 0, 1, 2, 3, 4. So number 4, this one number 5. So 5, except B and E, turn off. B and E. Okay, then you get number 5 lah. Okay, Ati? Hello? Ati, okay?
Okay, understand.
Alright. Okay, so next you can do yourself lah. Okay. So we move back to this code. Okay. We move back to this code. Okay, so statement 0, which is your LEDs must equal to 7 bit. Okay, F4 B bit. So 0, which number? This one, right? Okay, then put this one back. Put this one back straight away. So I put this one back. So all numbers, this one, I put this one. Then close. Okay? And then case 1. Case 2. Okay. So case 1, you copy this one. Can you hear me? Lag, right? Lag.
Yes, sir. Like quite.
Lag, right? Yeah, that's why.
Yes, sir. Yes, sir.
But can you hear me or lag?
Yes, I can hear, doctor. It's a bit lagging. I can hear, but can hear.
Okay, good. Tutorial. Okay, later I can share this file to you lah. Easier for you.
Okay.
Okay, so this one first one. Okay, so now you want to do case from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So why until 9 only? Why? Because your display until 0 until 9 only, right? Okay, because you have the number from
Yes,
0.
that's only 9 because only 9 we can.
Correct. Okay, good. Okay. Now 0, 1, 2. So this one 3. I make it easier for you. 4,
Sure, thank you.
5, 6, 7, 8, 9. Okay, so everything's similar. 777 because 7 bit. Okay, and you put the number at this at the location. So 0, this one 1. So you put number 1.
Okay,
2.
understand that. So 1, 2, 3, 4, 5 until 9. That's okay.
Yes, correct. Easy, right?
Yes, easy. That's it.
0,
It looks
0, 1,
complicating, but
2.
then when we break down to formula, it's quite easy to answer.
Yeah. Because maybe I'm typing, so it looks complicated. 3,
Understand that.
3, 4. Which 0, 1, 2, 3, 4. This one 4. Okay. Because I want to show to you step by step. I don't just straight show the answer because you will not understand. 2, 3, 4, 5, 5 or 5. Okay. 6. If you write it on the paper, of course, it will take more time lah. Easier for me because I just copy and paste. Okay, 7, 8,
Yes, sir.
and 9. Okay. So like you code these numbers with this BCD number. Okay. So 0 until 9 is the real number lah. Real number that will appear in this LCD or LVB. Yeah. Okay, then because there are some numbers that are not here, right? Because this one
Yes,
always
sir.
0. So there are certain cases because if 7, you still have some probability, right? Like 1010, 1011, 1100. Okay, 1100 is not here, right? Okay, 1100
Yes,
after
sir.
this number is not here, right? Okay,
Yes.
like 1001, 1010, 1010. What else? 1011. Sorry, and then 1100, 1101, 1110, and 1111.
Oh, this is A,
Okay,
B,
so for
C,
this
D.
case, yeah, in your previous subject, maybe you learn you code 0 to 9 or A, B, C, and something, right?
Yes, but
But
then it's like,
for this subject, yeah, but for this we just put don't care.
okay.
The answer is don't care. Because we don't code until A and so on, A, B, and so on. Okay. But
So under 7
this,
bit only understand.
yeah, but this number are here, right? But there are no answer, right?
Yes,
Okay,
sir.
so we have to code it. We have to code all these numbers and into the answer, one answer, which is by default. Okay, so put the default. Okay, default. Small, small, not
Yes, sir.
capital. Default LEDs equals to 7-bit XXXX. Is it 7? 1,
6.
2, 3.
It's 6. The
One more. One more. Okay. 7 right now?
yes, sir. One more X.
Okay. So
Yes, sir.
from these numbers, because you cannot program to your 7 segment. Okay. Because there is no answer for that. So, but you cannot leave it blank because sometimes when you do simulation, your processor or your quarters 2 calculate wrongly. So sometimes they fall under this region. Okay. So that's why we have to declare it as don't care or XXXX. So let's say when you do your program, you got XX mean it fall under this region lah. Okay.
Okay, sir.
You don't want to use it. You just use 0 to 9. Okay. So default LEDs 7BXX and case. Okay. Then you end case because your statement is case. Okay. This is the case. So you must end it lah. End case. End case. And for your module, you must put end module. Okay, bold. Okay. So this is the code lah. So quite longer.
Okay, sir. Can understand. Can understand. Even
Okay.
it's long, it's understandable.
Right. Hopefully you understand because
Yes, sir.
because it is quite important because this is the basic or not. Never mind lah. I share to you that word lah.
Can, doctor, can. Share the word, doctor. Just put in the group. I can skip.
Yeah. Okay. This one you don't use it lah. This table. You use my table. Can I delete this table? Oh. Don't use it lah. Use it in my ni. Okay. So far clear. So good.
Clear. Good.
Okay. Okay. Next we move back to this answer that I asked you about the conditional operator, right?
Yes, sir.
Okay, so what is the answer? Cannot write here lah.
Yeah, I think it's to the this one, apa? Adopt Accord without using Acrobat. Yeah.
Never mind. I put in the spreadsheet only. This one word easier for you. Okay, so this one previously. Okay. Sorry, quite tricky this online.
It's okay, doctor. It's okay.
Takes time,
Doctor,
right?
yeah, it's okay,
It
doctor.
takes
You are
time.
teaching me, doctor. It's okay. You gave me a knowledge.
Yeah, because I like to show to student, not just read, but if no choice, I just read lah. But because this subject is the practical one, right? So it's slow,
Yes.
step by step. Okay, right. Okay, so never mind. I write back.
Can, doctor. Can. I wait.
So code using conditional. Sometimes I use my pen, digital pen, but I don't like that because it's more complicated. Okay, conditional operator. So this one based on previous exercise lah. Okay, so you have module. Box 2 to 1. Okay. Okay. Oh, sorry, you cannot see. Okay, now you can see. Okay. Marks 2 to 1. Then your input and output I0, I1, A, Y. Right. Okay. Then semicolon.
Yes, sir.
Input
Yes, yes.
in 0, in 1, standardized. If you want you use capital, all you need to use capital. If small, you need to use small. I0. Sorry, not in. I0.
Understand, Doctor, understand. So if you
I1.
small, it's all small.
Okay. I0.
If big alphabets, farm.
Yes, correct. Yes, yes. You have to follow this one. What you declare here? If you declare big I, you have to put big I lah. If you use small I here, you will get error lah.
Understand that.
Okay. So input I0, I1. What else? A, right? A is the input, right? Okay. Then output. This one also input and output also small,
Yes, Doctor. A and Z.
Cannot big.
Yes, Doctor.
Otherwise you will get error. Output is Y.
What is
Okay.
Z, Doctor? Z.
Oh, sorry. This one Y. Y.
Why,
Because
sorry, sorry.
because later your Y will be equal to Z. No worries lah. We use this one. Okay. We use this equation. Okay. So apa Y? So they say use with conditional operator. So conditional operator, if you use this one, conditional operator, this one means double dot and also this one, right? Okay. Okay. So how to use conditional in this case? You declare input output, then you assign Y equals to A okay, I0, I1. Okay, I0, I1. And module. Okay. So this is how to use conditional operator. Okay, Ati? Okay, Ati? Hello, Ati.
Doctor, can you hear me, Doctor? I think my line is quite bad.
Yes, yes,
Doctor?
yes. Yes.
Sorry, Doctor. My
Just
Wi-Fi
hear
is
you.
quite
I
bad
just
here.
I just heard you.
Sorry, Doctor. Sorry, Doctor. But I was
Is
like,
it okay?
yes, okay. Because Doctor was talking, and I was like, "Hey, Doctor, no sound at all." I'll say, Doctor, Doctor. Sorry, Doctor.
Oh, okay, okay. So, which one is the last one?
Doctor, I was hearing until the module marks 2 to 1. Then that's all. Then we see already.
Okay, okay, okay. Never mind. Okay,
Sorry,
I
Doctor.
repeat.
The KSJ Wi-Fi is quite slow, Doctor.
Yeah, I think my internet also slow today.
Oh, because normally the KJ Wi-Fi is like sometimes it's good, sometimes we'll do some stuff lah. But at least I'm still on the WebEx. For some classes, I'll be getting out of WebEx only.
Oh,
Sorry,
so
Doctor, sorry.
okay, it's okay. That's why I turn off the camera to save the bandwidth.
Understand, Doctor, understand.
Okay, so I repeat back. Okay, so from this exercise, the last exercise that I asked you, okay, about this one, data flow coding using conditional operator, because this first one is Boolean expression. Okay, Boolean means you use symbol and or to replace your add and multiply. But for conditional operator, you use this symbol. Okay, symbol like question and double dot. Okay, so how to use this type of symbol? First, your module is same. Okay, okay, so your module is similar. Hello, Ati.
Doctor, I can hear you, I can hear you. It's
Can
similar,
eh?
I can hear you.
Okay, okay,
Can.
okay. Because I heard the noise. Uh, okay, and then marks 2 to 1. Okay, so I1, I0, A and Y same right? Okay, same. Input
Same,
same.
Doctor. Yes.
I1, I0, A and output Y and assign Y. So this one if you use Boolean expression, but for this one you do uh, conditional operator. You put input, output and assign Y equals to, you want to check, okay? You want to check the value, right? So check the value of A. So A, question mark, okay? I0 to I1, okay? I0 double dot I1 means you want to check the number of A and the number of I0 and I1. Okay, so this is how to write lah the conditional operator. So the function is same with this Boolean expression, but this one in the conditional operator. Okay, because how to get A question mark? Because this A appears into, okay, into condition which is in A, in I0 and also I1. Okay, so you want to check A with I0 and I1. Okay, whether if A is true, okay, if A is true, then the result of the expression is B, or the result of expression is I0, else the result is I1. Okay, so I put the statement here. Okay, so if A is true, then
Understand, Doctor, understand.
the result of expression is B. Sorry, is I1, I0, else I1. Okay, so this is the comment lah, statement for this line. Okay. Okay, T?
Okay, Doctor, okay. Can
Alright.
understand a bit, Doctor.
Okay, so We rest for 10 minutes and then we continue for next slide.
Can the time? Okay, I'm okay.
Okay.
Can.
All right. Okay, thank you. Okay. Ready ya?
I am ready, Doctor. Ready.
Okay, cool. We do some ni lah. Some part lah. Okay.
Okay, Doctor. Exercise. We're going to the second slide, Doctor. Okay, Doctor.
I see second slide is quite advanced lah. So I think we cover basic first. Because
Can.
another because that one involve arithmetic logic, because if you don't really understand basic part, I'm afraid you will lost lah. So better we do one more exercise. Okay.
Can, Doctor.
Okay. 2 to 1 marks. So if else 2 to 1 marks. Okay. We back to 2 to 1 multiplexer, because there are other techniques that you can use. Okay, so this one is your your 2 to 4. This one 2 to 4. Okay. I want to show 2 to 1 multiplexer. So
Okay,
4 to okay, this one 2 to 1, right?
Hmm.
Okay, this one is 2 to 1 multiplexer. Beside this technique, I will teach you another one technique. Okay, another one technique. Okay. 2 to 1 marks. Okay, 2 to 1 marks. So module marks. So this one I write different name lah
Okay, Doctor.
Okay. So they say I use this one. So your 2 to 1 is here lah. Okay, I put the diagram. Okay. Last week I saw the Tamil movie in TV2.
Doctor, what movie, Doctor?
I forgot the name, but something about politician in India. But really, for me, it's really nice movie lah.
What's the movie title name, Doctor? Got so many movies in there.
I forgot lah.
In India, Tamil, Telugu, they have the same ideology. I mean, like, in a year, they got hundreds political movies released, so it's
Okay.
difficult for me to answer. I have to say when there's a political movie, I'm avoid.
Okay. Later I will inform you the name. Okay. So
Can that thing?
1 marks. Okay. So same. Put your name I0, I1, A, Y, right?
Yes, A is input,
Okay,
Y is
then you
output.
put okay.
Input A.
Input
A.
I0, I1,
I1 and A.
A. Okay, close.
Output Y.
So also close. Okay, output Y. Okay, correct. Okay. Okay, close. Then you want to store in the register, right?
Yes, Doctor.
Okay, register Y. Okay. Okay, so because this is just one bit, so you don't have to put 0 to 1 lah, or 1 to 0. Okay, just 1 bit. Always. Okay, this one I want to use if else. If else. Very long. Okay, if else. Okay, always add in 0 or in 1 or A. Okay, so you want to use if A equal to 0, Y equal to in 0. Okay, so this is always statement lah, if else. Okay, so if A equals to 0, okay, if A equals to 0, your Y equals to in number 0. Okay, input 0. Okay, so else, when you have if, of course you need to have else lah. Else Y equals to what else? You already have in 0, so another one in 1. Okay, in 1, then you end module. Okay, okay, okay. This is another way lah to use if else.
Understand? This is a simpler way, Doctor.
So that's why I teach you last week this one at the end of the class.
Understand, Doctor.
Because easy, this one easy. Okay, so if A equals to 0, this one is the symbol of equal is like equal lah, like this one, equality. Okay, use equal. Okay, if not equal, this one. Okay, so equal. Okay, if equal 0, Y equals to in 0, if else Y equals to input 1. Okay, so same like same like this one, right? I0 equals to 0. If A0, I0 0, A1, I1 equals to
Yes, sir.
1. Okay?
Okay, understand, Doctor.
Okay. We do one more.
Can, Doctor.
Okay, now we do 4 to 1 marks. Okay, 4 to 1. This one 2 to 1. Now we do 4 to 1 marks. Okay, I want to find picture for 4 to 1 marks. Oh, not here. Okay, never mind. I will try find picture first for 4 to 1 marks. Okay, 4 to 1 marks using if else. Okay, first find the diagram first.
Understand. What is the 4 marks, Doctor? Understand.
Okay, this one 4 to 1 marks. Okay. So with enable pin lah. Okay. Sometimes you find enable, sometimes no enable. Okay, okay. I find no, try to find no enable first lah. Okay, this one easier. Okay, copy image. Okay, so this one 4 to 1 marks without enable. Okay, so how to code? First, module, marks 4 to 1. Okay. So I, S, Y. Okay. Why I just declare I as Y and not I3, I2, I1, I0, S1, S0? Because this I is considered 0, 1, 2, 3, 4 bits. Okay, 4 bits. So I can use 0 or I can use 3 to 0. Okay, and this one 2 bits. I can use 0 to 1. Okay.
So the input is
So
I3, I2, I1, I0, S1, S0, SO. Output is Y, right?
yes, correct. Okay. And then input. Okay, because I use I and I'm not using I3, I2, I1, I0. I use I, so I have to declare here how many bits. So I we have 4 bits. So 3 to 0. Okay. And then I. Okay. Boleh hati?
Clear, clear.
Right. Okay, next. Input, output. Output how many bit? Output just 1 bit, right? So Y lah. Okay, you have another one input is here. You have another one input, right? S, right?
Yes, sir.
Okay, so input, how many 0? 1, 2, 0. Because just 2 bit.
Oh, okay, understand.
First, because 0, 1, 2,
Oh,
3.
okay. So the I
So
is
4
equal
bit.
4 I. So
Ah,
3 output 3.0, while the S is 2 only. So 1.
ah.
Okay, I understand.
So if 1, 1, 2, 0 lah, dot, double dot here is like 2. Bit number
Oh,
1
understand.
and
It's
bit
like
number 0. Yes,
replacement
this one.
anything can happen with that.
So this one bit number 3, bit number 2, bit number 1, bit number 0. So bit number 3 to bit number 0. So this is bit number 3, bit number 2, bit number 1, bit number 0. This is bit number 1, bit number 0. So bit number 1, bit number 0. Okay? Because here you declare general. As a generally you declare. So this one you have to declare more specific lah.
So we got 6 output, but based on the outputs with the I. So 3.0, while the S is equal to 1.0. Okay, understand. So you have to
Okay?
declare to the numbers. Understand that?
Yeah. So why doesn't have this one? Because
Because
why
why
just
only
have
one
one?
output at there?
Correct. One output or one bit. Okay?
Understand that?
Okay. Next, output register lah. Okay, register Y because you want to store the value. Okay. Okay, register Y, then always, okay, add X or, sorry, not X, I or S, okay. This is your input, okay. I or S is your input. So this is your input I, this is your input S, so you put together here, I or S, okay. Because
Understand that?
you want to use later. At the bottom part. Okay. So because you like if, so I use if lah. Or this one for if, right? Example for if. Okay. So if S equals to 0. Okay. Y equals to X1 or I1.
Yes, sir.
Sorry, I0.
I do.
Okay. If your switch here is 0, means 0, 0. Your I is I0. If 0, 1, I1. 1, 0, I2. 1, 1, I3. Okay. This is 4 to 1 marks lah. Concept of 4 to 1 marks. Okay. Next. Then if S sorry, else if S equals to 1. Okay, this one doesn't matter, space or not, but if you want to, if you do handwriting, basically put some space, okay. Y equals to I what? I 1. Okay. Sorry, forgot to close. Okay. Else if S equals to 2, Y equals to I 2. Else if S equals to 3, Y equals to X or I 3. End module.
Understand, doctor. So this is quite a shorter version, doctor.
Okay, Ati?
Okay, doctor, this is quite a simplified version, doctor. 4 multiplexer.
Okay, easy, right? If S0 0, you get I0. Okay, so this is I0 for selector, multiplexer. If S is 1, 1 means 0 1 lah. 2 1 0, 3 1 1. Yeah, okay. If you convert in the binary. Okay, this one because you use if else, so you can use decimal number lah. S equals to 1. Okay?
Okay, doctor, I understand, doctor.
Right. Right, so I think that's all for today, Ati.
Okay, doctor, I'm okay with it, doctor. Doctor,
Right.
doctor, okay, no, doctor, for doctor.
Okay, because I have to do some some important tasks. So
Yeah, I understand.
I think we finish until here lah. Actually, this also complete the first week of the notes lah.
Okay, doctor.
Okay, no worries lah. Okay,
Sure, doctor, no
so
worries.
I will share with you this one.
Can doctor share in
Okay.
the normal class group also can, or personal also can, doctor. Anything also I can, doctor.
Alright, I share in the group lah, easier.
Can, doctor, can.
Alright. Okay, Ati.
Okay,
So
doctor.
any question?
So far, no, doctor, but if I do revision, I got then I message doctor lah.
Alright, sure, good. Okay, so we will